Hello students, welcome. Previously in Form 3, Topic 2, Lesson 9, we were dealing with molarity of a solution. In Lesson 10 today, we are going to do preparation of molar solutions. How are we going to prepare molar solutions? So we start with first of all knowing some of the apparatus that are used to prepare molar solutions. Those apparatus include volumetric flask. Remember, volumetric flask comes with different sizes. Like you can have a volumetric flask with 250 centimeter cube, or you can see one with 500 centimeter cube or milliliter. You can have a volumetric flask with 1 liter, a volumetric flask with 2 liter, or even with 5 liters. So we have again measuring cylinders, the same again. Measuring cylinder can come with different measurements, like you can have one with 10 ml or 10 centimeter cube, or you can see one with 50 ml or 50 centimeter cube, or you may come with that of 100 ml measuring cylinder in plastic or in a glass form. So we start examples. You can be told during the exam, describe how a molar solution of sodium hydroxide can be prepared. So a molar solution of sodium hydroxide can be prepared. Okay, there are several answers here because you have not been given any values or any condition. Like we have not been told using 250 ml volumetric flask. So the question is, in other words, open. So we are told describe how a molar solution of sodium hydroxide. So what is first of all molar solution? We said molar solution. Molar solution, you said, is a solution that contains 1 mole of a solute. 1 mole of a solute. In 1 liter of a solution, or in a liter of a solution. In a liter of a solution. This was the definition for molar solution. So what does 1 mole of a solute means? That means solute is, in our case, the sodium hydroxide. So that means you are supposed to know the mass of that solute. So, or in other words, the molar mass of that solute. Okay, how do you write sodium hydroxide? Sodium hydroxide is written NaOH. So what is the RFM of this sodium hydroxide? Sodium is 23 plus 16 plus 1 for hydrogen. This one is giving us 40 grams. So that means for us to prepare a molar solution of sodium hydroxide, what we can do, we can take 40 grams of the sodium hydroxide pellets, then we are going to dissolve in a liter of a solution. So what we are going to get is a molar solution, or 1 mole or 1 molar solution of sodium hydroxide. That's one way that we can do. Second way, what we can do is we can just divide this 40 gram into 2 so that we have 20 grams. Then we also divide a liter divided by 2. We are going to get half a liter, or 500 centimeter cube. So if we take 20 grams, then we dissolve in 500 centimeter cube again, still we are going to have a 1 molar solution of sodium hydroxide. So even you can use another conical flask, another volumetric flask of maybe 250. So what we are supposed to do is we have divided 500 centimeter cube by 2 so that we get 250 centimeter cube volumetric flask. We are supposed to also divide this 20 grams so that you have 10 grams. Then you dissolve in 250 centimeter cube using a 250 volumetric flask so that you have the molar solution of sodium hydroxide, or 1 mole sodium hydroxide solution. So we have all those options because the question we said is open. Okay, to answer, we are having weigh accurately 40 grams of sodium hydroxide pellets or flakes and place it into a 250 centimeter cube beaker. So this is the beaker to put the solute. Then we add about 200 centimeter cube of distilled water in the beaker and we stir it to dissolve. So transfer the solution formed into a liter volumetric flask, because here we said the mass of the solute that we have taken is 40 grams. So this 40 grams we are going to put in a liter. That means we are going to use 1 liter volumetric flask. Okay, then you rinse the beaker with distilled water and transfer it into the volumetric flask, because that beaker that you are using in dissolving or forming the solution of sodium hydroxide, when you have transferred the solution to the volumetric flask, it still has some traces of the solution. So we rinse so that we remove that traces of the solution. So rinse the beaker with distilled water and transfer it into the volumetric flask. Then you fill the volumetric flask with distilled water using a wash bottle up to the mark. That's the last procedure. Okay, next we are going to go to question 2. Or before we go to question 2, if you are using this other side of having or taking 20 grams of sodium hydroxide pellets and dissolving in 500 centimeter cube, we can go back to the procedure again. Then we change only some small parts, because the procedure I give you here is the general procedure of preparing molar solutions. Okay, you can take weigh accurately 20 grams. You put here 20 grams. 20 grams of sodium hydroxide pellets, and you place it into a 250 centimeter cube beaker. Then you add about 200 centimeter cube of distilled water in a beaker, then stir to dissolve. Transfer the solution formed into a 500 centimeter cube or 500 ml volumetric flask. That's what we are going to say there. If you want to change the mass to 20 grams of sodium hydroxide instead of 40. Okay, you rinse the beaker with distilled water and transfer it into the volumetric flask. Then you fill the volumetric flask with distilled water up to the mark using wash bottle. So only the change will be on that side of 40 grams, you make it 20, and also the volume, or the measurement of that volumetric flask. It's supposed to be 500 ml instead of 1 liter volumetric flask. Okay, question 2. We are told explain how a 250 solution of 1.0 mole potassium hydroxide can be prepared. So we're having here K, which is 39, and we're having oxygen, which is 16. We're having hydrogen, which is 1. Okay, what is the mass of solute of that potassium hydroxide that we are going to have with 1 mole? So that means we are going to have potassium hydroxide written like this. Potassium hydroxide. So potassium alone is 39 plus 16 plus 1 for hydrogen. We are going to get 56. That means we are supposed to have 56 grams. Then we are supposed to dissolve in 1 liter of a solution to make 1 mole of potassium hydroxide, or 1.0 mole. So, but the demand of the question is, you are told how a 250 centimeter cube. How a 250 centimeter cube. So the first step, we are supposed to get the mass of the solute. That means if you divide this 1 liter to 4, you are going to have 250 centimeter cube. So you are supposed to divide also this 56 grams by 4, so you get 14 grams. You will get 14 grams. So this one will still give you the molarity of 1.0 molar. So that means we are supposed to use 14 as my mass of the solute. Or in other words, you can use the mole concept to calculate the mass of the solute. How do you calculate mass? First of all, you have to get moles. You have to get moles. So moles is given by molarity times volume used over 1000. Okay. Here we are going to get 250 divided by 1000. We get 0.25 moles. Okay, next step, if we get moles, how do you get mass? Mass is given by moles times RFM. So RFM of potassium hydroxide is potassium for 39 plus 16 for oxygen and 1 for hydrogen. This is 56. So mass will be equal to moles, which is 0.25 times 56. This we are going to get 14 grams. Okay, so if we have our mass, we are going to use only the original procedure in our question number 1. Then we are going to change only some small parts. So the first step, we are going to say weigh accurately. We are going to say weigh accurately 14 grams of potassium hydroxide pellets, or potassium hydroxide, and place it in a 250 centimeter cube beaker, full stop. Then after that we say add 200 centimeter cube of distilled water, and stir it to dissolve. After that we say transfer the solution. Transfer the solution formed into, so we say a 250 centimeter cube volumetric flask. Full stop. So you say rinse the beaker with distilled water, and transfer it into the volumetric flask. So you say fill the volumetric flask with the distilled water up to the mark. Using a wash bottle. Full stop. So that means you can have the initial procedure for question number 1, then you only change some small parts. Next, we are going to go to question number 3. So in question number 3, we are told describe how a 500 centimeter cube of 0.5 molar copper 2 sulfate can be prepared. So in bracket, we are having Cu to be equal to 64, S is equal to 32, then we have O is equal to 16. So we do the same. We are going to get the mass of the solute first of all. Mass, if you want to get the mass of the solute, the first step you have to get moles. Moles, we are going to get molarity 0.5 times volume used over 1000. Okay. So we are going to say, we are going to get 0.25. Okay, 0.25 moles. So what is the RFM of copper 2 sulfate? Copper 2 sulfate is written like that, so it will be 64 plus 32 plus 16 times 4. Here we are going to get 160. So how do you get mass? Mass is given by moles times RFM. So my moles is 0.25 times 160. We are going to get 40 grams. So if we are having 40 grams, the procedure is as usual. So we are going to say weigh accurately. We are going to start weigh accurately 40 grams of anhydrous copper 2 sulfate, and place it in a 250 centimeter cube, or you can say 500 centimeter cube beaker. Full stop. Add 200 or 400 centimeter cube of distilled water and stir it to dissolve. Then stir it to dissolve. Full stop. Transfer the solution formed into a 500 centimeter cube or a 500 ml volumetric flask. Full stop. Volumetric flask. Full stop. Then we say rinse the beaker with or using distilled water and transfer it into the volumetric flask. Full stop. So you say fill the volumetric flask. With distilled water up to the mark. to the mark, full stop, or you say using a wash bottle. So you are done with your question, which you are told describe how a 500 centimeter cube of 0.5 mole or molar of copper 2 sulfate can be prepared. That's all for today. Thank you.